Numbers unravel. Let's unravel this problem. In this problem, we are going to make use of the systems of linear congruences to find a solution that satisfies the equation simultaneously. To review, a system of linear congruences is a set of equations where each equation is congruence, an equality concerning remainders, and involves linear expressions, constant multiplied by variables raised to the power of 1. To begin, we must eliminate one variable by multiplying each congruences by an appropriate factor. In this problem, we have the systems of linear congruences 5x plus 4y is congruent to 2 modulo 11, and 3x minus 3y is congruent to 3 modulo 11. We can multiply 3 in the first congruency, while 4 in the second one. That will give us 15x plus 12y is congruent to 6 modulo 11, and 12x minus 12y is congruent to 12 modulo 11, and 15x plus 12x will be 27x, and 12y minus 12y will be 0 is congruent to 18 or just 7 because we can take modulo 11 in the 18. This results in 27x is congruent to 7 modulo 11. Now, we can consider a number multiplied by the value of x, which is 27, and the product when divided into the value of moduli, which is 11, yielding the remainder of 1. It is possible that 9 and 9 multiplied by 27 will result in 247, and taking modulo 11 will result in 1x or just x. The 9 that we multiplied in 27x will likewise be multiplied in 7. And it will give us 63. And we will take here also modulo 11, which will give us 8. Therefore, the x will be congruent to 8 modulo 11. Now that we have gotten the value of x, we will move on to get the value of y. The approach will be the same as obtaining the x value. We will eliminate one variable by multiplying each congruency by an appropriate factor. We can multiply 3 in the first congruency, while 5 in the second one. That will give us 15x plus 12y is congruent to 6 modulo 11, and 15x minus 15y is congruent to 15 modulo 11. Subtracting these two congruences gives us 27y is congruent to 2 modulo 11. As previously mentioned, we can consider a number that can be multiplied by the value of y, which is 27, and the product when divided by the value of moduli, which is 11, will result in a remainder of 1. Since we also have 27, it is possible to use 9. That is, 27 multiplied to 9 will be 243, which when we take modulo 11 yields 1y or just y. The 9 that we multiplied in 27y will likewise be multiplied to 2 and will give us 18, and we will take here also modulo 11, which will result in 7. Therefore, the y will be congruent to 7 modulo 11. Thus, x is equal to 8 plus 11k, where k is an element of integer, and y is equals to 7 plus 11k, where k is also an element of integer. For verification, we may substitute the value of x and also the value of y into two linear congruencies to show that they are satisfied. We know that x is equals to 8, while y is equals to 7. So, 5 times 8 plus 4 times 7 is congruent to 2 modulo 11. It will get the result of 40 plus 28 is congruent to 2 modulo 11. That will be 68 is congruent to 2 modulo 11. And if we take modulo 11 to 68, we will get the remainder of 2. Thus, the first congruency was satisfied. The next congruency is 3x minus 3y is congruent to 3 modulo 11. So, 3 times 8 minus 3 times 7 is congruent to 3 modulo 11. It will get the result of 24 minus 21 is congruent to 3 modulo 11. So, that will yield a result of 3 is congruent to 3 modulo 11. Some of you would ask, why 3 is congruent to 3 modulo 11? The reason is that when we divide 11 by 3, the quotient is 0, then the remainder was 3. And since it is congruency, it is congruent if the modulo divides A minus B. And here, the value of A was 3, and B was also 3. And if 3 minus 3 is 0, then 0 divides 11. And that's how we unraveled the mysteries of numbers on Numbers Unraveled.